be from the Create group from the University of Southern Denmark, who will be talking about Blender and Tissue for architecture. Okay, so he will be with you in a while. Okay, and the second speaker will be Rudvik Deshpande. Okay, he is talking to, or he will speak to you about machine learning for architectural design. Rudvik is actually based in India, and both of them are here with us despite their very hectic schedule. So we really appreciate your presence, Alessandro and Rudvik. So without further ado, I will call upon Alessandro to wow you with his tissue. All right, Alessandro, let me just unshare my screen so you can take away from there. Okay, all yours. Let me just record, right? Hang on.
Yeah. Hello, everyone.
Yeah.
Hi, nice to meet you. And let me share my screen. Okay. So can you see it?
Yes,
we can see.
Okay. So yeah, I'm Alessandro Zomparelli. I'm part of the University of Southern Denmark, and I'm gonna talk about the use of Blender and Tissue for architectural project. The presentation that I'm going to show you is basically covering two different aspects of my work, of my activity. And one aspect is the use of Blender and the development of some feature for Blender and for the community of Blender. And on the other side is my work as part of the research group of Create and how I use Blender also in this work. So before starting, Blender is not usually considered as a software for architecture. Actually, Blender has been developed mainly for animation, and during the time, many features were added to the software. It's an open source software, it's free, and also it's developed by a very passionate community. And this basically gives a lot of development power to the software, because there are many brains around there that are adding and customizing the use of Blender for different purposes. And I think that there are some reasons why Blender should be considered not as main software for architecture, probably, but at least as part of the workflow, because it has some very interesting features that are not usually there in some software that are used in architectural field. I think that one of the most important feature of Blender is that it's a mesh modeler. So meaning that basically when you 3D model something with Blender, you usually have a lot of flexibility, something that is more difficult to have in a CAD software, for example. It have a cost because basically when you use mesh modeling, sometimes you don't have the accuracy and the precision that you can have with a CAD software, but you have a huge gain in terms of expressivity of what you're doing. Also, in Blender, you have modifiers. Modifiers are kind of filters that you can apply to a geometry that can easily articulate and increase the complexity of what you're doing in a non-destructive way. What do I mean when I talk about non-destructive process or non-destructive feature? Basically, it's something that is not losing any information of what you had before. Meaning that if you apply a modifier to a mesh geometry, you are not losing any information of what you had in your mesh. Also, Blender have vertex groups. Vertex groups basically allows to create maps of information, gradients that allows you to have a more procedural and smooth control of some feature. And also allows you to use Python as program language in order to customize and extend the possibilities of the software. In general, when you work with Blender, as I said, you have a lot of flexibility. You can create very complex and expressive geometries in a very simplified way. This is just an example of how, for example, you can use the physics that you have inside Blender, the cloth modifier, in order to articulate a surface that can be interpreted as an architectural surface. And using the modifier, you can easily create a triangulation on the surface, giving thickness to the segments of your mesh. And this is something very interactive and very easy to do in Blender. At the same time, there are some relevant projects around there, I think, that should be considered. And I think they can be quite interesting for an architect. And of course, there is Blender Beam that basically allows Blender to communicate with a Beam board, allowing to organize and basically manage properly the architectural information of your geometries. There is Sverchok. Sverchok is a project that basically was born as a clone of Grasshopper inside Blender. It became something different and more unique, but it's interesting how it's bringing the possibilities of modeling with a node-based interface. And the newborn is Geometry Nodes that basically allows you to customize and interact with nodes as well, creating some very articulated geometries. And in particular, in this presentation, I'm covering another tool that I'm developing that is called Tissue. While the other tool try to bring a procedural approach using a node-based interface, with Tissue, I try to keep things a bit more simple, and I try to take advantage of the manual interaction that you usually have in Blender in order to embed some very specific workflow that I found useful in my daily activity. Tissue is already shipped with Blender, and when you install Blender, you have already the possibility to activate this Tissue add-on, but I usually recommend to download the latest version from GitHub that have more features, and usually it's more stable. And basically, when I started to develop Tissue, I started to add some feature that I was finding useful in my work. And it started as a collection of scripts, but then growing, it became more organized. And for example, there are a set of tools that work specifically with the vertex groups that I was mentioning before that allows you to create those maps and also to cut the geometry, for example, according to the value of those maps of information. If we are talking about architecture, you can think at those information as something that is coming from the environment, something that is just part of your design, that is coming from some kind of texture or images, are just information that usually you can apply to the geometry, and then you can use them as a processing tool for changing the geometries that you're working with. Or for example, you can use those map of information in order to create some contour lines and use them as part of your design or just as tool for analyzing what is happening on your surfaces. But I think that the most famous and probably the core of the tissue add-on is the tessellate operator. Tessellate use a method. It's not a unique method. It's something that you can find in other tools. But what I was trying to do with Tissue was to basically try to keep this feature simple. What does it? What's the functionality of that feature? Basically, you can create a geometry that we usually call the component, and you can apply this geometry to all the faces of your mesh. A mesh geometry is usually represented by different faces, so it's not a continuous and smooth surface, but usually it's already divided and tessellated in different phases. And this feature allows you to create and multiply a component for every phase. In this small and simple animation, you can see how it works basically. This is the interface of Blender. You can create just two objects. The base object is the cube, and the torus, the donut shape that you see, it's the component. And with add-on, you can easily select one geometry and apply for all the faces of the other geometry. Because I think that is important to, it's important to keep the workflow non-destructive, you always have a possibility to refresh the result of what you have just done according to the changes that happen in both geometry that are involved. So if you change the base, you can easily refresh the tessellation according to the changes that you do. And also, there are because there are many features inside Blender, I also had to add several controls in order to take advantage of all the features that you already have in the software in order to create a nice communication between the two parts. There are many different techniques, but in general, they always are based on the same principle that you have a geometry that can be multiplied according to another geometry. And usually this is based on the individual faces, but sometimes there are also methods that allows you to work on portion of the surface and creating more smooth deformation of a component according to this part of a surface. And basically, you have to think about the tessellation as just a tool that allows you to create tilings of geometries. And the most simple way is to use the quad tessellation, that is the one that we have seen in the animation, or let me show you more into detail. So imagine that you have a component that you can see here on the left, and you want to multiply this component for all the faces of another geometry. So as you can see, basically, what T should do is just to multiply it and adapt the geometry to the different quad that you have on your geometry. When you have a base mesh, that is this kind of pavilion shape, that is more subdivided, meaning that you have a smaller faces, the component gets smaller according to that. So this means that the mesh geometry that you're using is not just a mesh that represents a generic surface, but have a very direct implication in the design of what you're doing. So when you create a mesh with some specific subdivision in quad and with a very specific topology, this is how it's usually called, topology of the mesh, means that this is affecting the design of what you're doing. So basically you are designing through the topology. The patch tessellation takes advantage of the subdivision surface method that are in the mesh modeling software, also called as a sub-D. And basically, according to them, allows you to smoothly bend and adapt a component along the surface, taking advantage of this smoothing method that is based on iterative subdivisions. And this allows to have more flexibility and also to create more smooth geometries along the surfaces. And as I was mentioning, there are other tessellation methods. So basically, when you see a pattern around in nature or just in a regular building, you can try to understand what is the basic unit, what is the component that is underlying this design that you see, and how and which is the rule that has been applied in repeating and multiplying this component. So when you use, for example, this method that is called the fan mode, basically you can work with a generic polygon, and every polygon is subdivided in triangles that defines the different wedges of this polygon. So when you use this method, basically your component is not applied directly on the polygon that you have, but is multiplied for every side of the polygons, reaching the center of the polygon itself. This is interesting because it allows you to create very complex and sometimes unpredictable patterns, but on the same time, it's a bit more tricky because it's not that easy, especially for a beginner to understand how a specific component is creating a global effect. As you can see, it's not that easy to predict what is coming out from the component and the base mesh without watching the tessellation that you have on the right. So this is quite difficult at beginning to predict how to change your design according to this result. And this is why I think that working in a non-destructive way, it's important, because this allows you to do some adjustments, some iteration to see what happened and to make correction according to that. The frame mode is similar to the previous one, but in this case it is more focused on creating a geometry that is applied along the edges of the polygon and the faces that you have. This means that you can create those particular frames pattern, customizing the shape of the frame itself. So what I think it's interesting in this case is that because you are working in a mesh modeling software, you can quite easily alter and change the geometries of the component that you have. And the effect that you have when you multiply that for all the frames around all the polygon, it's something also in this case, sometimes a bit unpredictable, but that have much more for experimenting. And this is just, those are extremely...
No, it's just
Sorry? Sorry? So those are the very simple methods that you can use for multiplying the geometry on a surface, but there are many parameters that you can actually work with, and that allows you some more complex levels of customization. I started to use this add-on not specifically for architecture. I was working on a very wide spectrum of projects. Some of them were related with fashion. So basically, this is just a tool that allows you to multiply things along other things. So this means that you can apply in a very different range of possible application. For example, for fashion, if you work with 3D printed patterns, you can create geometries that have some specific property, like being elastic according to the specific shape that your component have. And you can create this kind of spring material, just taking advantage of the property of the geometries. Or, for example, you can create some patterns that are applied and multiplied according to a bidimensional surface in order to make these patterns that can be printed directly on the fabric. Or for any generic use, for example, the possibility to approach any modeling challenge, just thinking about a simple element that can be multiplied and distributed along a surface. In this case, for example, you can see how the color of a simple geometry that you have in the background are basically informing the specific component that is applied for the final tessellation. So changing the colors that you see in this image, you can just define which component is going to be placed in some specific part of the helmet. And same principle, for example, for medical devices, where you try to understand what are the parts that you need to apply to the different areas of the surface. And according to that, you can create different components that have different features, like this seam connection or some holes for the porosity, and all the features that you need to embed in your design. Or for architecture, this is, for example, a workshop that I did some years ago in Dubai. And here we were working on tensile surfaces in order to experiment with catenary systems. And in this case, we use the tessellation and tissue in order to understand how some components can interlock each other in order to create a stereoatomic structure that can be 3D printed and assembled together without the use of glue, for example, because all the components are perfectly interlocked each other. And inside the Create group, I joined the group, starting to look at the research that we were doing. So you can see it's a very wide spectrum of work that takes advantage of the emergent technologies in architecture, such as robotics, 3D printing, timber assemblies, and so on. And in particular, I jump in the research that is related with the use of 3D printed formworks for the production of concrete casted element. So here on the left, you see this formwork that has been 3D printed. And on the right, you can see this casted concrete panel. There are different challenges, and according to the geometry of the formwork, you can see how expressive you can get when you create those panels. And those are some experiments that have been done in order to by the group in order to understand the different geometrical challenges that you may have. And it seems that the workflow is quite able to reproduce a very wide range of different geometries. This is a different example of how you can use the 3D printed formworks in order to create some architectural element node connection that can be assembled together. And looking at this case in particular, you can see what are the challenges that you usually have in this kind of project. You have some structural elements that are inside the node. So you have those beams that are in steel that have to be welded at the center and the core of the node, and they must be positioned in some way. In the same time, you have the mold that should be 3D printed that should have a shape that allows you to obtain the specific geometry that you have to produce, and also must have some seams that allows you to open it once the material has been cast. So What we did now after that was to start this research project about the construction of an element that is a canopy based on a polyhedral description of the forces that are used as part of the process for generating the structure. And this canopy is made with different elements that can be assembled and disassembled in order to build and unbuild the structure. And as you can see, this structure have some features that are sometimes aesthetic, like the flutes and those lines that follow the structure that you can see, and other features that are part of the construction process, like, for example, the seams, the separation between the different parts. This is just a render because this is a work in progress project. But from here, you can see what are some of the challenges that we had when we had to basically design the structure and design also the molds that are being used for building those different structural elements. Here, you can see, for example, a polyhedral description of the starting diagram and the geometry that we had starting from that. And basically, the feature that you have seen in the render are following two main directions. The longitudinal direction, that is the pink image here, and the transversal direction. While the longitudinal direction is used mainly for the aesthetical and some functional feature, the transversal direction is used for separating the element in order to assemble them together. Why are those directions important? Because if you remember when I was talking about the topology of a mesh and the role that this topology have in the description of the design, well, in this case, the topology of a mesh should embed these two specific directions. So in general, when you work with this complex geometry, you have a mesh that is not really structured. It's something that have a bunch of polygons that can be quad or triangles that are assembled together in a very chaotic way. There are some algorithms that allows you to make something more, bit more clean, a bit more neat with some quad faces. But most of the time, what you get at the end doesn't really work in these two specific directions. So as you can see here, sometimes something that is longitudinal happen to be transversal for another element. So this approach of processing a geometry that has been already created before didn't prove to be good enough. For that reason, we had to work with a different approach, describing since beginning a specific geometry that is based on the polyhedral that we had in the starting diagram, in order to have this clear separation between longitudinal and transversal direction. And basically, we use a method that, starting from the polyhedral description of the geometry, automatically create this mesh geometry that have this property. So this feature is inside tissue, and it's called the polyhedral wireframe. So you can see from this video what happened basically is that you have all those polyhedra that are packed and fused together, and you can use just the modeling tool that you have in Blender in order to transform it and edit it in a very flexible way. You can use this method that is called proportional editing in order to make this smooth deformation. And because everything is connected, here you have a smooth deformation that it's quite can be quite organic. Then you use this tool, and it basically creates the thickness around all the faces of your polyhedral complex. You can decide the thickness, and after that, you can use this subdivision surface in order to make it a bit smoother. And what happened is that because the tool is being developed as part of the tissue pipeline, you have these nice and continuous loops that works in the two directions. And basically, taking advantage of this direction, you can create a component, and you can apply this component on the geometry in order to start to articulate some specific pattern according to this specific structure that you have. So here you can clearly see what is the relationship between the different polyhedra that you have on the left and the property of the mesh topology that you can get. And basically working with different shape for the components, you can create features that are articulated in one direction, in another direction, or even diagonally. So starting from these three components that you see, you can basically create these specific patterns. And as it was mentioned also before, sometimes it's a bit unpredictable, but you can also, I mean, you can be surprised from what it happened. I mean, it's unpredictable, but there is a clear rule. So at the beginning, probably it's a bit tricky, but while you use the software and this approach, basically you start to realize what you have to do in order to achieve some specific effect. But just think this as a geometric problem. It's not something that is specific for the software, it's just a geometrical composition problem that you have to start to understand. This is an exploded view of the node of a node of a structure, and from this you can see what are the many parts that we have. And the white part that you see here are the part that we are 3D printing in order to cast the concrete inside. And as you can see, there are some longitudinal features, like for example the presence of those arches that you have here, and also the seams, the separation between the different shells. And those are following the longitudinal direction, while the separation, basically the cut of this node, are based on the transversal direction. So the topology of the structure was quite important in order to achieve and control those specific qualities of the object. Of course, there is some dimensional control, because the different elements should have a standard steel plate connection between each other in order to simplify the structural consideration behind that. But after we did this dimensional control, it was possible using the tessellation to think at this system of shells as component. So here you can see what is the aspect of a component that has been used. So we have a simple component that is the first one on the top, that is called the fluid, that basically allows to have this movement, to this wave movement of a shells. And this component embed both shell geometry or part of a shell geometry and the surface of a concrete. This is just for a geometrical description, it's not part of a workflow. And we have two different geometries for the seams that basically embed part of one shell, part on the other shell that overlap on the same seam, and also the arch, that is the blue one, and again, the concrete surface, all of them packed together. What happened is that using the tessellation and using a specific series of colors that affect where every component is going to be applied, we have a mold, basically an assembled version of the mold. From that, we can separate the different parts and send them to the production for 3D printing. While the concrete surface is not used in the production, because the concrete is coming just from casting the material inside the mold, is used only as a tool for visualize the design and make choices about some changes that we may want to do. Also, the process involved another tool that is Grasshopper for Rhino, that allows more complex and elaborated parametric workflow. And for that, I use another add-on that I'm developing that is called Mesh Sync, that basically allows you to easily send the geometry from one software to another without altering the indexing and all the structure of a mesh, and basically allows you to create a more smooth transition between the two different softwares. And basically, once we 3D print the different part that you see on the left, all the part that has been 3D printed, they are combined together with a steel element, and basically the arches that you have seen are used as a positioner for keeping the steel element in a specific position in order to allow to weld them in the top here. So once the rebars, the steel rebars, are welded together, we can close the mold and we can cast the concrete. Here you can see some of the images of the production. So you see the 3D printing of one of the shells. You see here the positioning of the rebars before welding them. Here you can see the weld process of the rebars in the center. And after that, we had to close the mold. The mold is ready for casting. You can see also the size of the object. Here we pour the material and we extract the final piece. This is a structure that is still in production. We are in these days working on another prototype and probably the first part of a series of the final pieces for building the structure. And as you can see, this is a very peculiar approach for this kind of object. But the thing is that once you get into the system of paneling strategies or tessellation strategies, how you want to call them, basically you can approach many different challenges and many different problems with this specific approach. So you can use this type of tool for facades or of a building, for organizing different elements on the ground, or for example, in this case, to articulate a series of aesthetical and functional properties according to a geometry, as far as your topology allows to work with this specific direction. And that's all, and thank you.
Thank you, Alessandro. Okay, are there any questions from the participants? Anyone who wants to ask Alessandro anything? We can open up the Q&A for a short while.
Yeah, I know that some parts maybe were a bit fast, so if you have some specific question, don't be shy.
This session is recorded, so it will be posted in the website as well. Yeah.
Hello. Yes, I'm Moonway. I'm from DG. I have some question. Actually, for the Blender, it's not normally used for architectural students, right?
Yeah.
So actually, is it difficult for architectural students to learn and use this tool?
This is a good question, and I think that the answer is a bit personal, because I think that in general, learning a software that is far from the CAD logic can be a bit difficult at the beginning. I remember I was using initially AutoCAD and Revit, and when I started to use some mesh modeling software, I started actually with 3ds Max, and after that I moved to Blender. It was a bit confusing because you have this feeling that you are lacking precision, and it seems that everything is not in control. And this is the most annoying thing at the beginning, because you are coming from an environment that probably prevent you to do a lot of things that you may want to do, but in the same time, it keeps everything under control and safe for you. So there is a bit a different paradigm when we move to another software. This doesn't mean that you can't be precise in Blender or in a generic mesh modeling software. It's just that it facilitates more the creativity and the expression of what you're doing, instead of facilitating how precise you can be in your work. I think that this paradigm shift is the more complex things when you approach this type of software. I think that Blender is not a simple software. It's not like SketchUp. I mean, SketchUp has been designed in a very smart way in order to allow you to open it and basically start using since time zero. While in Blender, there is a lot of complexity, but also a lot of power. It's a tool that is used for mesh modeling, for creating animation, for rendering. So once you get into the software, there are many things that you can do with that. But at the beginning, it can be a bit confusing. But I think that if you stick to that, it may give you some satisfaction. Because as you have seen, I also use that for the render that you have seen in the presentation. I use that for creating the graphics that you have seen in the presentation, and also I use for making animation of my project. So once you start using the tool, actually you realize that you can use that for many different aspects. And I think it's an interesting software to have as part of your pipeline. It's not probably gonna replace the software that you use normally, but in my case, for example, is a very important part of my workflow.
I see. Thank you for the very comprehensive.
Hi, Alessandro. I have a question. Hi, Tian Xiong here. I'm from Singapore Poly. I noticed you use a few tools. I think predominantly Blender and Grasshopper.
Yes.
Is there a reason why you toggle between the both? Is it because one software does something better than the other, or can you explain a bit of your workflow? Yeah.
Yes, sure.
Because you know, like Grasshopper, they have so many third parties plugin available. And of course, your tissue is definitely one level higher than some of the plugins available. I mean, in Grasshopper, there's box morph, but yours apparently can also morph onto octagonal shapes more than 4 sides, 3 sides. You know what I mean? It's very different.
Yes. Well, that's a very nice question. And I started to use Blender initially for the wrong reason, not the wrong reason. I mean, I was attracted mainly from the open source community and this aspect of the software. But and initially, Blender wasn't really great in terms of feature. After some years, I realized how it was growing and how many features were put into Blender. And I started to use that as a very valid software in part of my workflow. And basically, I think that the best thing that I like in Blender is that you can easily manually interact with what you're doing. If you can create probably the same geometry that you have seen here in Grasshopper somehow, but the thing is that in Grasshopper everything is described in a more parametric way. It's not a bad thing. It's just that sometimes you want to have a more direct and manual interaction with your geometry in order to experiment a little bit more. So I like to use Blender because it allows me to easily work in a hybrid way, where some parts are parametrically controlled, while some other are just manually controlled. And for example, I like to drawing, and I started to enjoy a lot the mesh modeling features. So I feel good in an environment that gives me this flexibility in terms of modeling. And at the same time, I use Grasshopper because, of course, it's a more standard software for architecture, have tons of plugins that you can use and connect with a regular architectural workflow. So I think that Grasshopper is still a very important part for a computational designer / architect. And I like the connection between the two because, I mean, I don't like to stick to just one software and be constrained by what you can do in this specific software. So I think it's important to create some transversal workflow that move from different pieces of software. And I personally enjoyed a lot Blender because, because of the flexibility, the user experience that I have. I like it. Sometimes it's just something personal. Maybe there is people that use Maya, for example, that cannot use Blender because they learn these kind of things in Maya and they feel more comfortable in this environment. For me, it's the opposite. I started to use Blender. Is probably the most advanced software that I start to use really with mesh modeling. And I really enjoy the experience that I have in Blender. And when I have to do something, usually I do that in Blender if it's possible. Otherwise, I switch to another software if it's not possible. But usually for me, it's the first choice. But this is really personal. I mean, I think that everyone have a software that for one reason or another gives you a better feeling in the experience of modeling and that you prefer to use when you have to create. I like Blender because it's really flexible. So it's like starting with a pencil and a piece of paper instead of starting with a ruler and a compass, for example.
Thank you.
You're welcome.
All right, thanks, Alessandro, for the detailed explanation on the FAQ. Okay, we have to move on to the next speaker. Okay,
hi, good afternoon.
Yeah,
Hi.
so
I have
we will invite. Oh, sorry, you have another question?
Yeah, one quick question to Alessandro.
Okay, sure.
Thank you very much for the presentation. Just a quick question. Would this Blender have you tried to model water or waterfall for it?
Sorry?
Water element. Model water element.
Sorry, again, sorry?
Yeah, modeling the water element. Water as in river, waterfall, water flow.
Ah, okay.
Yeah. Would this be a good? Yeah.
Well, not specifically. There is some fluid simulation that you can use in Blender. I use that more as a toy, as just for playing, because I like to experiment with all the feature of a software, even if they are not really part of my work, but because I want to know what the software can do. But no, I personally haven't. But I think there are some nice examples around there of the use of the fluid simulation that you can have in Blender. I mean, these things can be approached in two different ways. You can make a proper fluid simulation, or you can just make something that looks like. So you can maybe model something, and with a smart use of a texture, you can maybe have this kind of effect. But yeah, no, personally, sometimes I play with those things, but not something that as advanced as this one.
Okay, thank you. Thank you very
You're
much.
welcome.
I would like to ask a short question if we still have time.
Mm-hmm.
Okay, so
Yes,
I
go
would
ahead.
like to. Okay, so I would like to ask, is there any way to produce a conventional shop drawing for fabrication? So as industry people only understand typical 2D, and Blender is kind of like can't do dimensions in Blender, right? If I'm not wrong.
You mean producing just
Shop
the
drawing, yeah.
yeah.
So after we design, we have to proceed for construction. So we have to yeah.
Well, to be honest, I wouldn't recommend Blender for this specific task. I don't think it's made for that. But for example, when I want to create some drawings starting from Blender, I can create some SVG files that are vector graphic files that then I use inside the software like Inkscape or Illustrator in order to add some details. But if I really have to make a CAD software, a very detailed and precise, a CAD drawing, a very detailed and precise drawing, usually I move to Rhino because I think have a wider set of tools at the moment. So, I mean, you can somehow do that, but I wouldn't probably recommend that because it can be a bit annoying. But if you're really passionate about the tool, you can find your way to make something, but it's not probably the simplest way to do that.
Okay, thank you very much.
You're welcome. Thanks.
Hello, Professor. Hello, Professor. Can you hear me? I want to know does there any software can assist architectural design in Blender? I see Blender is a great modeling of software.
Yeah, sorry. Can you repeat the last part?
I say the Blender is a great modeling software, but I want to know does any software inside the Blender can assist architectural design?
Well,
such as there are visual EQ in Rhino. Did it and does there any software like this kind of software in Blender?
Well, in Blender, there are some add-ons designed specifically for architects that allows you, for example, to make some beam-ish modeling, creating walls, element, and windows and doors, and allows you to articulate some common architectural element. And yeah, there are others that have libraries, for example, with furniture, something that you can use for making some renders of an indoor view. And yeah, there are some add-ons that have been developed in order to facilitate, let's say, the basically, yeah, the architectural drawing inside Blender. As you have seen, I'm focused mainly in something that is a bit more advanced. So I'm usually more interested in the complex modeling as feature for Blender. But there are things that allows you to. So there are some add-ons that you can install that allows you to create a regular architectural environment and mainly designed for rendering and animation, but also facilitating the transition for architect to the software.
Okay,
all right.
thanks.
Okay, thank you for for all your FAQs. Okay, if there are any other further questions, they can reach you via email, Alessandro?
Yes, sure.
Is that the email that is shown on screen now?
Yes, exactly.
Also?
Exactly.
Yeah.
Definitely.
Okay. So yeah, this session will be recorded, so you can actually reach for Alessandro on the email there. Okay. Thank you,
Okay,
Alessandro,
thank you.
for your time
Thank you again.
and the sharing.
Thanks.
Right. Okay. We would like to invite now Ludwig Deshpande